Okay, today we're going to look at slope in section 5.1. So the slope of a line is a number determined by any 2 points on the line, and we represent slope with the letter M. There are a couple of ways to think about slope, and I know you've looked at this before, but slope is the ratio of change of the y coordinates to the change of the x coordinates. So when we say ratio, that means a fraction or a rational number. And we're going to do the change of y. Change of y means what's the difference between the two y coordinates, and the change of x is the difference of the x coordinates. So one way to look at it is with this formula, which I know you've seen before. And let's just write these down and we'll use them in a minute. So the ratio is the change of y sub 2 minus y sub 1 over the change of x. Another way we refer to this is the rise over the run. When y changes, that's an up and down difference or a rise. And when the x changes, that's a left and right difference or a run. The last way you may not have seen before, this symbol is the Greek letter delta. So we read this as delta, delta y over delta x. And in math, the Greek letter delta means change. So this is also saying the change of y over the change of x. So just another symbol or notation that we can use for slope. All right, so let's look at a few of these. Let's say we have two ordered pairs, -1, 2, and 3, 4, and I want to find the slope. So I'm going to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now these little numbers down here are subscripts. They're just there so that we can tell the difference between the two ordered pairs. Oops. So if I call this, hold on, I've lost my tool. Oh, I don't know what happened. Oh, there we go. All right. So if I call this my first ordered pair, or x sub 1, y sub 1, and I call this the second ordered pair, x sub 2, y sub 2, then I can input the numbers. So y sub 2 minus y sub 1, 4 minus 2, x sub 2 minus x sub 1, 3 minus a -1. So that's 2/4, which is 1/2. So this slope is a positive slope. It has a rise of 1 to a run of 2. Now let's look at that at the graph and see what that means. -1, 2 is here, and 3, 4 is up here. When I move from this point to this point, I am moving up 2 units, and I'm moving to the right 4 units. So my rise is 2, and my run is 4. So by looking at the graph and counting rise over run, I can get the same slope as doing it algebraically. Let's do another one. Let's look at -1, -2, -4, comma 1. I'm going to do the algebraic method first. Y minus y, so starting with my y sub 2 minus my y sub 1 over my x's. So that's 3 over -3, which is -1. And let's look at that on a graph. So on the graph, -1, -2, -4, 1. And again, if I go from one to the other, first doing my rise or my up and down, I'm going up 3 units, and then I'm going to the left 3, and going left is negative. So my rise over run is also 3 over negative 3. And that's the slope of the line that passes through those 2 points. Now notice that when I did the slope between these 2 points and my slope was positive, my line went up as I moved from left to right. When I get a negative slope, my line is going down as it moves from left to right. So that's an important thing to keep in mind. Let's do a couple others. Let's do 1, 2 and negative 1, 2. So again, doing my y minus y, 2 minus 2 over my x minus x, I get 0 over negative 2. Okay, so let's look at this on the graph. Sorry, my pen is going crazy again. So 1, 2, and negative 1, 2. My rise is 0. As I move from one point to another, I don't go up and down at all. I just go right and left. So my rise is 0 over my run, which is 2. So a slope of 0 denotes a horizontal line. No rise, just run. Let's do one last. 1, negative 2, 1, 3. I'm going to go ahead and graph this first. 1, negative 2, 1, 3. Now I have a run, or excuse me, I have a rise. I do go up and down. As a matter of fact, my rise is 5, but my run is 0. I do not go right and left at all. 5 divided by 0 is undefined. Let's do it algebraically. Y minus y over x minus x gives me 5 over 0, undefined. So when a slope is undefined, I have a vertical line. So let's look at that put all together. We can use these slopes, therefore, to classify our lines. If we get a positive slope, the line rises or moves up as it moves from left to right. Okay. If I have a negative slope, the line falls or moves down as it goes from left to right. If I have a 0 slope, the line is horizontal. If I have an undefined slope, something over 0, I have a vertical line. And the last thing we want to talk about is absolute value of the slope. The bigger the number, absolute value means just the value of the number. Don't care if it's positive or negative. But a slope of 5 over 1, which would be very steep. A rise of 5, from this point I would go up 5 and to the right 1. A slope of 5 is much steeper than a slope, say, of 2. A slope of 2, I would go up 2 and to the right 1. So the bigger the absolute value, the steeper the line is. It might be steep going up, it might be steep going down. Doesn't matter if it's positive, negative. That's what absolute value means. All right, so the last thing we want to do, well, excuse me, second last, is to find a missing coordinate from the slope. So if they tell me to find the value of x so that the line through these 2 points has a slope of 3. Well, let's look at our formula. So I've got several of these missing parts. I don't know what x sub 1 is, but I do know what y sub 1 is. I do know x sub 2, and I do know y sub 2, and I do know my slope. So my slope is 3. In other words, this ratio has to equal 3. Y sub 2 minus y sub 1 over x sub 2 minus my unknown value. So how am I going to solve this equation? Well, the first thing I'm going to do is to simplify the numerator, and I'm going to write that as 3 over 1. Now I can use my cross product. 3 times 1 minus x equals 1 times negative 6. 3 minus 3x equals negative 6. Subtract 3 from both sides, and x equals 3. So in order for these 2 points to create a slope of 3, we need x to be positive 3. Now, the last thing for real, the rate of change. Rate of change is a slope that relates how a quantity changes over time. So for example, if I am traveling, find my, oh, let's do it this way. If I am traveling 300 miles, I start at 0 at my house and I go 300 miles, and it takes me 5 hours. My rate of change, the change in miles, the total distance in miles is 300. My change in hours is 5 hours. And if I simplify this, 300 divided by 5, I get 60 miles per hour. So a rate of change is simply a slope that relates how a quantity changes over time. In other words, it's a slope with units applied to it. So miles per hour, feet per second, anything that we can do with some sort of unit measure over time is called specifically a rate of change. It's just a fancy name for particular slopes. And that's all we're going to look at for right now.